Alright, welcome back to the second half of Paper 2 for your Term 1 Year 10 exam. Let's have a look. We're up to question 9, first of the complex familiar questions. Not overly complex, but just trying to get you to think in a slightly different way. That's probably what makes it a bit more complex. It's not very standard. Possible to successfully solve this equation either by dividing each side of the equation by 3 or by adding 18 as the first step. Show me that you can do it each way. Okay. 3x minus 18 equals 21. I'm going to divide each side by 3. Making sure I do that correctly, I'm going to be left with x minus each side, x equals 13. Not too bad. The other side, 3x minus 18 equals 21. Add 18 to each side, 3x equals 39. Divide by 3, x equals 13. Okay, he's giving us away marks on a complex familiar. That was nice of him. Explain why the second method, adding 18, is preferred. Okay, so we know that we think about this as like, you've got to get rid of whatever's got the least to do with the x first. So the 3's joined up with the x, the 18's separate. I'm going to get rid of that bit first. Why? Because we can produce a fresh start. So you want to say something along those lines. Subtracting 18 first. Oh, adding 18. Look at me. I'm not reading my own question. Adding 18 first prevents errors such as forgetting. The most common one is definitely forgetting to divide 18 by 3. And avoids fractions. Pen playing up a little bit there, sorry about that. And avoids fractions until the final step. For ease of calculating, that will do. It says to come up with an example of why it might be easier. Let's just consider, all you really need to do is make sure there's no common factor between A and B. So why don't I just keep the numbers simple? 2x minus 5 equals 7. Okay, let's do it by dividing by 2 first. I'm going to be left with x minus 5 over 2 equals 7 over 2. X equals 5 over 2. X equals 12 over 2. X equals 6. Can certainly get there doing it that way. Is that as easy as 2x take 5 equals each side? I've got 2x equals 12. Divide by 2. X equals 6. You can clearly see the second method is the preferred method. It's a lot faster and easier, and you're less likely to make a mistake. All right. Getting towards the end, to ford the mythical sword of Duquesne. I don't know how many of you have ever watched Community, but if you have, I hope you got the reference there. If not, and you're bored over the next 6 months, maybe that'll be something you can have a look at. To forge the mythical sword of Duquesne, 2 swords made of bronze were melted and forged into one. The first sword was an alloy of 12% tin and 88% copper, and the second was 23% tin, obviously 77% copper. The final sword contained 18% tin and weighed 1.24 kilograms. Calculate the weight of the first sword. Well, we've got a couple of different things here. Let's define some variables. Let x, I'm very creative, aren't I, equal the weight of sword 1. What do you reckon y is going to equal? I think you've got it. Weight of sword 2. I can write a couple of equations now. The first one I can write is that the 2 swords together weighed 1.240 kilograms. So x plus y equals 1.240 kilograms. I don't really need the units there. We just need to be aware of them for our final answer. That's okay. What I was trying to write there was, I'm going to call this my first equation. I've got 2 unknowns. Chances are I'm going to have 2 equations to be able to solve these. What's the other one? I've got, the final sword contained 18% tin. So they're the only 2 things I know. I know that, and I know the percentage of the final sword that's tin. So what was that made up of? Oh, that was made up of 12% of sword 1's weight plus 23%, 0.23 of sword 2. Together that makes up 18% of 1.240 kilograms. So once you've got those two equations, you're ready to go. Again, I think it's going to be much easier for this one using substitution. As much as I love my elimination, I'm going to go y is equal to 1.240 minus x. I could have done x equals 1.240 minus y, but I know I'm looking for the answer x. So if I can keep x and get rid of y, I'm going to get to my answer faster. This is not one where you need to find the weight of both swords or anything. I'm only interested in the first one. So I want to keep x, I want to get rid of y. That's the way I'm going to be able to do it. I can substitute that into the other equation. So in equation 2, which I didn't label, I'm going to say let y equal 1.240 minus x in equation number 2. All right, and we're away. So now I've got 0.12x plus 0.23 times 1.240 minus x equals, and 0.18 times 1.24. I prepared these earlier. I don't have a calculator on me now. What have we got there? 0.2232. We do a bit of tidying up on the left-hand side here. I've still got 0.12x, a little bit of expanding. 0.23 times 1.24, again referring to my little answer sheet here, 0.2852. And then minus the 0.23x equals 0.2232. Tidy up that left-hand side. Need a little bit more room. We've got plenty here. How many? I'm going to have 0.2852 minus 0.11x. And that's equal to 0.2232. Equating my terms together, I am left with 0.062, so subtracting the 0.2232 from each side, 0.062, and adding 0.11x to each side is going to equal 0.11x. Final step, doing my division, if my pen wants to work. Therefore, x is approximately equal to, I divide by 11, and I've got, oh, it's going to be exactly equal to, that's nice. Well, exactly equal to mathematically, probably measurement-wise, they rounded off somewhere anyway, but that's okay. 0.5 and then 63 recurring kilograms. And it's nice if you can write that in words. The first sword oh my goodness, weighed 0.5 and then 63 recurring kilograms, and you are done. Can you hear that they've stopped the blowers? Can you believe the blowers are still going, even though there's almost no one here? It's quite loud. All right. Question 11, complex unfamiliar. Sketch the equations. Oh, we've got inequalities to sketch. This will be fun. Let's start with the easy one. Y is greater than 0. So I need to sketch y equals 0. What is y equals 0? It's just a line along the x-axis, because that's where every y coordinate is 0. I'm just going to make my pen a little bit thicker, so it's going to show up nicely for you, hopefully. I'm doing a dotted line. Why am I doing a dotted line? Because, as we know, if it's a strictly greater than or strictly less than 1, it does not include points on this line, and we indicate that by using a dotted line. Now, you could start shading now. I like to shade at the end, and whether you shade the side, the region you need or the region you don't need, that's up to you to indicate. All I'm writing myself there is a little reminder near the end. I want to keep the bits above. That's definitely where y is greater than 0, above that line. I'm going to hang on to those. Let's choose a different pen. The pink pen here, we're going to do x plus 3 is greater than 0. What's that equivalent to? X is greater than negative 3. Well, I know where x equals 3. It's a vertical line. Oh, negative 3 is a vertical line going through negative 3. Of course, this is a greater than question. So again, a dashed line going through that section there. And I want all the x's, I want the region where the x's are greater than that. Well, you can see straight off your number line, these ones are nice and easy. It's definitely to the right of that where my x's are greater than -3. Lucky last. 4x plus 5y minus 8 is less than 0. It's annoying, they haven't given it to us in a nice form. Let's use the intercept method. If I've got my x and y on the same side, I almost always use the intercept method. Let's see how we go with this. I'm going to let x equal 0. Let x equal 0. Therefore, 5y minus 8 equals 0. Remember, I'm solving for the equation being equal. It's not very good when my stylus doesn't work as it should. 5y equals 8. Y equals 8 over 5. What's that the same as? 1.6. I've got roughly a y-intercept right there. If you want to find the y-intercept, that's my y-intercept. Make a note of that if you want to. For my x-intercept, let y equal 0. Therefore, 4x minus 8 is going to equal 0. 4x equals 8. X equals 2. So that is my x-intercept. Now, I'm writing all around up the top here. You've got plenty of room underneath. It's more video that I'm doing the notation there. Please use the space provided. I'm just trying to make it a little bit easier for you guys to keep the question in focus while we're doing that section. So I've got x equals 2 there. So what I actually need to do now is draw a dashed line going through those points. Now, it's a bit tricky for me to do this particularly accurately on my OneNote, but hopefully you get the idea. The next thing I need to do is to be sure that I keep the correct side of that line. How do we do that? Well, let's test a point. What point would I test given the opportunity? I would test the origin. So long as it's not on the line, I'm going to test the origin and just check and see whether it satisfies the equation. So what was the inequation? It was 4x plus 5y minus 8 is less than 0. So 4 times 0 plus 5 times 0 minus 8. Is that less than 0? Yep, -8 is less than 0. Tick. So I keep the side that contains the origin. So I want the side that is down and to the left of that. So really, what have we got? I'm going to decide to shade those that I don't require. Now, it's only very loosely. You will very clearly see what region is required. So that pink region disappears, and